We physicists have waited a century since 1916 for this photograph. Renowned physicist Dr. Michio Kaku, a trailblazer in theoretical physics, has dedicated his life to uncovering the deepest mysteries of the universe. Now he's embarked on a mission to challenge and potentially rewrite the fundamental laws that govern our reality. Widely recognized as one of the greatest scientific minds of our time, Dr. Kaku boldly suggests that our existence might be nestled within the confines of a black hole. Just imagine the profound implications, our entire understanding of time and space encapsulated within the immense gravitational grasp of these cosmic enigmas. But what exactly is a black hole, and how did it form? Join us as we explore this captivating journey, delving into the extraordinary possibilities concealed within these cosmic phenomena. Alongside this exploration, we'll examine recent images captured by the James Webb Space Telescope, which may reshape our understanding of the universe's origins. According to leading scientists, black holes are far from mere empty voids in space, they are intricate cosmic wonders. These colossal concentrations of matter, compressed into unimaginably small volumes, possess a gravitational force so intense that even light cannot escape. Despite their invisibility, their presence is evident through their profound impact on surrounding matter. Some black holes are surrounded by swirling disks of gas and dust, emitting vast amounts of radiation and earning the title of quasar, the universe's most dazzling entities. But how do these mesmerizing phenomena come into existence? Scientists propose various types, notably stellar black holes formed from the collapse of massive stars and supermassive black holes residing at the hearts of galaxies like our own Milky Way. While the precise formation mechanisms remain a mystery, theories range from stellar collapse to mergers of smaller black holes or the absorption of nearby stars over vast time scales. Recent observations by the James Webb Space Telescope challenge established theories, particularly regarding the universe's birth. Dr. Kaku, known for his forthright views, highlights the telescope's groundbreaking discoveries, including the detection of galaxies just 500 million years after the Big Bang, galaxies 10 times larger than our Milky Way. This revelation poses a significant puzzle. According to current understanding, such massive galaxies should not have existed at such an early cosmic epoch. Dr. Kaku emphasizes the need to reconsider and potentially revise our understanding of the universe's origins in light of these puzzling findings. These galaxies, containing billions of stars, emerged when the universe was still in its infancy, raising profound questions about cosmic evolution and the fundamental laws that govern our existence. The timeline of galaxy formation depicted by these recent discoveries challenges current models, suggesting a faster and earlier evolution than previously thought. This intriguing puzzle may necessitate fresh insights from physics or the development of novel techniques for galaxy creation. As aptly noted by Dr. Kaku, the groundbreaking revelation of these universe breakers underscores the James Webb Space Telescope's ability to provide a novel perspective on the cosmos's early history, challenging existing notions and urging exploration into uncharted territories of knowledge. Astronomers from Swinburne University of Technology in Melbourne, Australia, led by Evol Lobby, made a significant breakthrough by analysing photos taken by the JWST in July 2022. These images, capturing a small segment of the sky, revealed 6 galaxies of exceptional brightness and reddish hue, previously undetectable by other telescopes. Utilizing photometric redshift estimates, the team determined the galaxies' distances from Earth, revealing incredibly high redshift values ranging from 9.5 to 11.5. This implies that the light from these galaxies originated more than 700 million years ago, challenging previous records. Further analysis revealed the astonishingly large stellar masses of these galaxies, ranging from 10 to 100 billion times the mass of the Sun, rivaling or exceeding that of our Milky Way. These findings contradicted conventional theories of gradual galaxy growth, suggesting a rapid transformation of gas into stars. Additionally, discrepancies emerged concerning cosmological theories based on studies of the cosmic microwave background, as these galaxies contain more mass than anticipated for their respective regions of space at that time. The presence of old and red stars in these galaxies raised questions about star formation and chemical enrichment in young environments. To address these disparities, scientists considered alternative explanations, including the possibility that these objects might not be galaxies but rather quasars or other active galactic nuclei fueled by supermassive black holes at their centers. These findings underscore the complexity of the early universe and the need for continued exploration and refinement of our understanding. However, the absence of distinct spectral signatures expected from active galactic nuclei in these objects raises questions. The formation and accretion of matter onto supermassive black holes typically require time, making it rare at such high redshifts. Another possibility is that the models and theories used to interpret the observations were flawed, leading to uncertainties about these galaxies' evolution. Further exploration and analysis are necessary to unravel the mysteries surrounding these extraordinary galaxies and shed light on the mechanisms behind their formation and evolution. These processes may involve the creation of colossal galaxies within a brief time frame, without relying on mergers or recession. Alternatively, these galaxies might be outliers that emerged under extraordinary conditions or in rare regions of space, rather than being representative of the general population at that time. These anomalies could potentially challenge our understanding of cosmology or physics, suggesting novel events or interactions beyond the scope of current models. Dr. Kaku speculates that factors such as the annihilation of dark matter or primordial density fluctuations could have influenced the early universe's volume and distribution of matter, resulting in variations in mass and faster expansion in certain regions. Additionally, evidence for new dimensions or additional forces, such as those proposed in string theory or modified gravity, could impact our understanding of the universe's fundamental laws. While these are theoretical possibilities, they underscore the need for further investigation and testing with more data, and improved models in the years to come. The James Webb Space Telescope, equipped with a range of instruments capable of conducting comprehensive studies, is expected to provide more information about these peculiar galaxies and their implications for cosmology and physics in the future. Meanwhile, in a fascinating development, observations by the James Webb Space Telescope have shed new light on the mystery of globular clusters, ancient clusters housing millions of stars within a confined space. Webb's findings reveal the intense brilliance of stars within these clusters, along with an abundance of nitrogen, suggesting the presence of giant stars. These insights offer clues to the formation and evolution of these enigmatic clusters, providing new avenues for exploration in the study of stellar dynamics and evolution. Amidst these revelations, Dr. Kaku offers an alternative explanation for recent discoveries, suggesting that the JWST may have encountered black holes instead of baby galaxies. This hypothesis challenges conventional theories of galaxy formation, proposing that these objects could be monstrous black holes born from the aftermath of creation itself. Such a notion hints at the emergence of new laws of physics within these mysterious cosmic entities, pushing the boundaries of our understanding of the universe.